All right, hello compaction class. This is Mr. Thompson coming to you from YouTube world. I apologize for having to do it this way, but this was out of my hands. So here I am. I'm going to try to teach your first real lesson from a video. I know this is far from an ideal way to learn, but this topic here is not super crazy. I think a lot of you kind of already did this first assignment anyway, but I'm going to go through this and I'm going to explain some things and hopefully it'll make sense. This is going to be the classwork. This is going to be from 6.1.2. So this is going to be about reflections, rotations, translations. We talked about this briefly with the key lock puzzles and things like that for your first actual assignment. But I'm going to go through problem 6-9 and 6-10. This is your classwork. And I want you to work on this with someone, maybe your elbow partner, someone right next to you. Kind of go through these questions, see if you can follow along and do this. And then, so you're going to go ahead and you're going to pause the video here. Hopefully the substitute teacher will pause the video. Then you guys are going to go ahead and work on this, see if you can answer these questions, and then we're going to come back, review the video, and see if you did it right. So now is the time to pause for a moment. All right, and hopefully you now unpaused, you've completed all the work, and we're going to go through this. So I'm going to start here with 6-9, where does it land? So it says, Felicia found a copy of a puzzle like the ones in 6-1. Those are the key lock puzzles that you did. But the lock is missing. All she has are the starting points and the moves to unlock the lock. This time, her key is shaped like a triangle, which is something that's going to be much more common for our transformations. The points are at A, B, and C, -5, 0, -5, 3, and -1, 0. So first thing we're going to do is we're going to go ahead and graph that. I'm doing this on Notability, so I've chosen the graph paper background, and I think that's a good idea for you as well. So Notability, if you do it better than I do, draws straight lines, and I'm going to make some mistakes today because I am going to do this all in one take. That's just how I roll, so hopefully you guys can bear with me and realize that I'm doing my best. I'm going to do it all in one take, and hopefully we're going to get through it and be just fine. So this is going to be my x-axis here, and this is my y-axis, and these are the units are going to be by ones. You don't have to mark them all. 1, 2, 3, 4. So that's 5. 1, 2, 3, 4, and 5. Missed it. And 1, 2, 3, 4, -5, and 1, 2, 3, 4, -5. So this is called the coordinate plane. I think you probably already knew that, but here it is, the x and y axes. And now we're going to go ahead and plot onto there Felicia's triangle. So A is at -5, 0. You guys should all know that x comes first, y comes second. So it's alphabetical in the coordinates, so -5, 0 would be found right there. That's -5, 0. Then -5, 3 is going to be 3 spaces above -5, 0. And then the last one is at -1, 0. That's right there. And so those are the vertices of her triangle. And we will use Notability to hopefully draw a triangle. There it is. Okay, so there's my triangle, or I should say Felicia's triangle. And again, this is going to be point A right here, point B, and point C. So that's the first thing you have to do. Now, step 1 is to translate 4 units to the right and 2 units up. So all you do is you take each of the vertices and count 4 right and 2 up. So if I wanted to translate point A here, oops, I'm going to do that a lot. Okay, point A, I'm going to just count from point A, I'm going to count 4 right and 2 up. So 1, 2, 3, 4, 1, 2. So that's where it's going to go. right there. I'm going to get rid of those little dots on there though. So 4 right and 2 up. Now, one little notation that you should start to be familiar with is that after you do a transformation of, say, point A, this would be known as A prime. Okay? Now, each of those other points you could count 4 right and 2 up. But the more algebraic way to do it, the more mathematical way to do it, is to go look at the coordinates and go, okay, well, this went 4 right, so that I could do plus 4 to that and get -1. So I'm going to write with a smaller pencil. There we go. So add 4 to the right, so that gives me -1, and then add 2, that would go, y is vertical, so that would go 2 up. So -1, 2, that should be the coordinates of where I ended up with A prime. So, and you can see -1, 2 is where that is. So let's do this with each of these here. So let's add 4 and add 2 to x and y. So plus 4 plus 2 is going to give me -1, 5. And then plus 4 plus 2 is going to give me 3, 2. And I'm going to put -1, 5 and 3, 2 in. So -1, 5 is right there. And that's going to be my B prime. And then 3, 2 right there is going to be my C prime. And we could draw that triangle now. I didn't do it quite as well, so there, fix it. Okay, so that's step 2, or step 1, I should say. Now step 2 is to reflect it across the x-axis. Where's the x-axis? Well, right there. That's the x-axis, so we're going to reflect it. What's it mean to reflect it? Well, that means we're going to think of the x-axis as the mirror. So it's like that point is looking into the mirror, and what's it going to see on the other side? Well, exact same distance away, it's going to see its reflection right there. So the simple way to do this is to go, okay, A prime is 2 spaces away from the mirror or the line of reflection, the x-axis, so we count 2 spaces past it right there, and that would be called A double prime. Do the same thing with C, so you go 1, 2, 1, 2, and that will take you to where C prime is. So that's going to be C prime. And then B prime, you can think, oh, well, it's going to be 3 past A prime, or you can think just how far is it from the line of reflection. 1, 2, 3, 4, 5. So you count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 past it. And that'll give you B prime right there. And so that's what it looks like after the line of reflection. And we'll adjust it just a little bit here. There and there. Good. Okay, so next, we're to rotate this triangle counterclockwise 90 degrees about 0.3, -2. So how are we going to do that? Let's go to green. So -3, -2. Where is 3, -2? Well, 3, -2 happens to be right there. That's where C prime is. Now, when I get back in person, I'm going to show you a much better way to rotate this triangle. But for now, the way we can do this is just think of this thing is going to be 90 degrees counterclockwise. So think about which direction does a clock go. So clocks go this way. So counterclockwise would be that way. So we're going to rotate this triangle about this point counterclockwise 90 degrees, which means if we were to think about just this side of the triangle, where would it go? Well, it's going to go 90 degrees. You'd make like a 90-degree angle right there, and that's where it would be. So how long is this? This will help us. 1, 2, 3, 4 units long. So let's just draw straight down from there. a line segment or a side that is 4 units long. There we go. Okay, and now if this goes down here, what's going to happen to this piece? Well, it's still going to be attached to it. And it looks like this is already a right angle there, so it's still going to come off at a right angle. And it's got a length of 3. It's not making it straight. Well, so it's still going to have a length of 3 over here. And so this would be, actually, I don't know why I didn't do that before. Should have called these double primes so that we knew that this was the second move. Apologize. This should have been double prime. This is what happens when you try to do everything in one take. All right, and then this here will be triple prime. That's our third transformation, and you can see B triple prime over here. And then to finish this triangle off, just go right there. Since we're rotating basically about point C double prime there, 3, -2, well, it doesn't move, so C triple prime is also right there at that exact same location. So now, that's all the steps. Says help Felicia find where the lock is by following the steps. The following questions are designed to help you. So here's our own grid, our own paper. And you can hopefully answer some of these other questions. How many quadrants? How should you label it? Hopefully you did all these things. And if we get down here, where does Felicia's triangle end up? Complete step 3 on the graph and then label the coordinates of each vertex. Okay, so here's where it ends up down here. This is after the final transformation. And it says, now compare the triangle in problem 6-9 that you have after step 3 with the original triangle. How do the lengths of the sides compare, and how do the sizes of the angles compare? Well, what they're really trying to get at here is, because this is the original triangle here, and this is where it ended up down there, what they're wanting you to notice is that these are going to be what's called congruent triangles, because all of these are what's known as rigid transformations. And a rigid transformation basically means you transform a geometric shape and it remains congruent to the original. So congruent means all the sides have the same length and all the angle measures remain the same. So it's a triangle that looks just like the original one, same size, same shape. It's just going to be somewhere else. It may be rotated, translated, or reflected, but it's still going to be same size, same shape. That's what rigid transformation produces, congruent triangles, and that's all they're trying to get you to point out there. So follow up to this particular lesson is what's called homework, and now you can have a little bit of time to begin it here in class, but the homework is 6:12 to 6:17, so spend some time working on that, 6:12 to 6:17, and then we will go over the next lesson